We have a sample problem here. A 2-meter long piano wire with a mass per unit length of 12 grams per meter is under a tension of 8 kilonewtons. What is the frequency of the fundamental mode of vibration of this wire? So when we look at our equations for standing wave on a string, the fundamental mode is F1. For a string, we can say this is 1 over 2L times the square root of the force of tension in the string, how tight the string is, over the linear mass density. Now, L is the length of the vibrating section. They haven't specifically stated vibrating section, but we have to assume that whole 2 meters is that vibrating section of the wire. They give us a mass per unit length of 12 grams per meter. We will want that in kilograms per meter for our units to work out. So all of it in SI units. They give us the force of tension as 8 kilonewtons, which would be 8,000 newtons. Well, this ends up being a simple plug and chug, actually, from there. So 1 over 2L, so L is 2 meters, times the square root of our 8,000 newtons. I'm going to rewrite newtons into its subunits because we know that is a kilogram times meter per second squared, and divided by this linear mass density in kilograms per meter. So I know I need it in kilograms per meter because I need those kilograms to cancel. This meters will come up here and give me meters squared, so that when I take the square root, this term is the speed. This term's going to be in meters per second. This meters is going to cancel with that meters and leave us with the 1 over seconds, which is our hertz. So it is good to follow the units through as best as possible. You don't always have to write them in all the steps, but make sure you are considering those units as you go through. So plugging these numbers through, I'm getting 204. And then, as we talked about, the units will be hertz. And we do have 3 sig figs. All of these numbers given to us are in 3 significant figures. So this particular piano wire would have a frequency of 204 hertz.